It is how much? 10 to the power of minus 15. How you got this 10 to the power of minus 15?
Sir?
How you got this 10 to the power of minus 15 size of the nucleus? Any idea that?
Sir, they've given it to.
No, given, but from where? Which experiment is explaining this? I have given you two
From gold
parameters.
foil experiment.
Not gold foil experiment only, but two parameters we discussed. One is impact parameter, another is closest approach. What is closest approach? The alpha particle come to the gold foil to certain distance and then it retraces back because of repulsion between the positive charge of the alpha particle and what gold foil nucleus. So that distance is 10 to the power of minus 15. So finally he said that it is the size of the nucleus. Tell me, what did I say?
Sir, you said that in the alpha particle experiment. Uh, can you repeat again?
See, you understood now alpha particle scattering in that one I told you impact parameter and closest approach. Is it clear to you or not? You tell me that. Yesterday what I taught
Yes,
you.
sir. It's clear.
Clear. What is closest approach?
So, like the point nearest to the nucleus, like alpha particle
Yes,
nearest to the nucleus,
correct.
before the
Alpha.
anti.
Yes. Alpha particle is come to the certain distance of certain distance, and it will retrace path. Correct.
Yes,
That
sir.
distance is called size of nucleus. That is only called size of nucleus. That is approximately calculated 10 to the power of minus 14. That is also called 1 Fermi, which I told you already. Fine now?
Yes, sir.
Okay, so here that is the one is given. Another one is what it is given? Radius of the orbit 10 to the power of minus 10. Okay,
Yes, sir.
like the earth orbit atoms around the sun.
Yes, sir.
So how this earth is revolving around the sun,
Gravitation.
same manner electrons are revolving around the nucleus. If the
Yes, sir.
dimensions of the solar system add the same proportion as these atoms, okay, would the earth be closer or further away from the sun? So 100 times it will be closer compared to this. So how to compare it is just simply you divide 10 to the power of minus 10 to 10 to the power of minus 15. How much it will come?
Yes, sir. Sir,
Ratio I am
something like
asking.
that.
Yes.
100 times because
No, 100 times
1 is
bigger.
to
How
100.
you arrived that I am asking.
Sir, first we found out like the distance between the orbits, sir.
Yes, correct.
And then we compared both the distance between
Okay.
the
Okay.
orbit of the sun and the orbit of the nucleus. And
Okay.
the radius of the orbit is directly proportional to the force experienced.
Okay. The radius
So
of the earth is how
we
much
can
it
directly
is?
compare.
Radius of the earth orbit is how much? 10 to the power of
So
5
radius of
into
Earth
10 to the
orbit
power
is
of
10 to the power minus 11, 10 to the
8.
power 11
So,
we said,
yeah, it will be
plus
equal to
11.
10 to the power of 13. This is more than 100 times greater than the actual orbit of the radius of earth. So which is while comparing what we got it generally, it is given what is the radius of the how much is the radius of the earth? Radius of the earth is 10 to the power of 11 and
1.5
the
to 10 to
radius
the
of
power
the
11.
sun is 10 to the power of 8. Okay, so that if you
Yes, sir.
multiply what you will get 10 to the power of 8, 10 to the power of 11 divided by 10 to the power of 8. it will come 3. So actually we got 10 to the power of 5. Here it is getting 10 to the power of 3. So how many times it will be? 100 times greater.
Yes, sir.
Still you didn't get properly, I think so.
I understood, sir.
Write and show me.
Yes, sir.
First you take the radius of nucleus, that is 10 to the power of minus 10 divided by 10 to the power of minus 15 you write. That will give you certain ratio value 10 to the power of 10 to the power of 5. Also you take the radius of the earth orbit divided by radius of the sun. So it will come 10 to the power of 3 approximately. We are not going exact picture but approximately. So it will become right here otherwise. Oh, what happened? Are you there? It is disconnected. I don't know why. Are you there? Hello?
I'm there, sir. Sorry, sir. My mic was on mute.
Okay. Got it?
Almost, sir. I'm still writing.
Just take the ratio of the electronic orbit to nucleus size. So it will be how much? 10 to the power of 10 to the power of how much it will be? 10 to the power of minus 10 divided by 10 to the power of minus 15. This will come 10 to the power of 5. You got it or not? This is the ratio of electron orbit by nucleus size, electron distance and nucleus. Then now earth divided by
Sir, yeah.
sun's
Not
orbit.
commenting, sir.
Huh?
Sir.
Huh?
Sir, you're not
Oh,
commenting,
I
sir.
am not shared. Ah, okay, sorry. When it is gone, huh? Oh, where is it? It is going so badly. Okay, this is the question, isn't it? Here, first you have to take electron distance orbit. Is how much? I just write here simply E divided by nucleus, which is 10 to the power of minus 10 divided by 10 to the power of 15. Correct? Hello?
Yes, sir.
This is how much it will come?
10 to the power 5.
Very good. Now, similarly, Earth radius and radius of the Sun. Okay, Sun's radius. How much it will be given here? 10 to the power of 10. Earth is how much? 1.5 into 10 to the power of
11.
11 divided by 10 to the power, that is 7 into 10 to the power of 8. So this is all, we will be approximately cancel them. Then what is the one will come? 10 to the power of 3. Right? This is coming, how much it will be? 100 times. When you divide them, 10 to the power of 5 divided by 10 to the power of 3, if you divide, you will get 10 square. So 100 times. So when you compare like this, your atomic atoms have lot of space. It is almost 100 times greater than that of the solar system when you compare the radiuses. Still it is not clear.
Yes, sir. I understood, sir.
Okay, next
I
this
got the answer, sir.
answer is not important. How to do it important. Okay, in the examination now you are doing objective type
Yes, sir.
means you can just put. But one remember this one you do it because you want mostly problems, is it not?
Sir, this is not the proportion.
Not there, it is.
The Giga medicine.
Ziegler Marsden is there now. It is textbook only. Ziegler
Okay.
Marsden only,
Yes, sir.
Rutherford model only.
So you said some experiment is not there, no, sir.
Which one? Oh, Davison Germer experiment, that is not there.
Okay, 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 yes, I understood, sir.
We are talking in second, now we are in atoms and nuclei. Just read the question yourself and tell me what is asking, what to do. If you tell and put the steps, formulas, calculation is not important, just put the things. If it is okay, I will go for next. You can open and see if it is very difficult to see the screen.
No, sir, I'll just stick to my textbook.
Do it your own. I want only on your paper. You have to tell what is given, what is asking, what are the formulas, what are the things you have to submit. You get. Don't do calculation. That you it is up to you. Steps will go fast, na. Every problem if you work out like this, and then your summary points if you remember, na. And another thing, madam sent something. You sent or madam sent, I don't know. That material. That material also very important, is it not?
Can you
No.
explain once again, sir?
Okay, here itself it is there, na.
Yes, sir.
The atoms. See, alpha particle is coming to nucleus and then closest approach trajectory. Then I have to take no, whenever you are free now, my YouTube you can open and see there. You will get a lot of informations, no. Anyway, I'll open now to show that. But this question is clear.
Yes, sir.
The system initial mechanical energy is before particle nucleus interact, and it is final energy when the alpha particle momentary stops. Okay, so initial energy is just
Yes.
kinetic energy and final energy is potential energy U. Okay, the potential energy of U can be calculated from how much you have to U from the 12.1, that means first chapter. Oh, that is potential energy we have calculated now. Already in that I have given. Let D be the center to center distance between the alpha particle and gold nucleus. And alpha particle is top point. Okay, then we can write the conservation. So this is kinetic energy half mv square, then it will be equal to final energy potential. With that you are going to get the D. D expression is this. This is the nucleus size, right? Nucleus size is calculated here this much. Z is taken this much. So approximately gold nucleus is that is 10 to the power of minus 14. Just now I explained there. So this value
Yes,
is
sir.
10 to the power of minus 15 is Fermi, I think so. One Fermi is how much you might have taught you. Red is better or blue is better color?
Sir, red is better.
Okay, this one objective type. All objective type
Yes,
questions
sir.
will come from the year only, my dear. One for me. They will ask you for me energy also I am going to tell you. Okay. So it is
Yes.
how many times? 6 for me's. The gold that size of this one is 10 to the power of minus 15, but we got it is 10 to the power of 16. So when you divide this, you will get 6 for me will come. This distance is called closest approach. May I draw and explain this?
Yes, sir.
Okay. Right, I will see. I will try for you to understand this. Okay, you look at here. This is your gold foil nucleus, correct? Understood? This is a gold foil. What is its
Yes.
atomic number? 79. Right? So this is equal to Z. Is it visible? Alpha particle is coming straight like this. And then it is going to very close to nucleus. And again, this is called kinetic energy. What is that? Kinetic energy of the alpha particle. Because alpha particle is positive charge, fine, and this kinetic energy
Yes,
will
sir.
be get stop here. Why? Because there is a repulsion force will act. Alpha. This is also gold foil also positive, and alpha particle also positive. Against the repulsion force, it is going, and at certain distance, it will be equal, right? And then it will retrace back, which I told you. This distance between the centers is called closest approach, which is called D. That value is how much it is
Yes,
given
sir.
formula 2 Z E square divided by 4 pi epsilon naught K. K is kinetic energy. How this derivation has come, you know or not? Which I have derived and shown you in the previous PowerPoint presentation.
Yes, sir. I remember, sir.
That is kinetic energy is equal to potential energy. Potential energy 1 by 4
Yeah.
pi epsilon
Yes.
naught Q1 Q2 means E square by D, right? D is coming this side. Okay, so 2ZE has come. Why 2 will come? Kinetic energy 2ZE will come, of mv square will come. So that is K. Kinetic energy is given there. Maximum kinetic energy found to be, this is the formula you remember. This formula you submit values. What is submitted here? This is a 2 is there in the equation, and this is 1 by 4 pi epsilon naught. This is E square, E means charge of electron, and Z means this. Z 79, if you submit, you will get this. So the final answer comes 10 to the power of minus 15. You just do it and show me.
Yes, sir.
Here 2 is coming, you know. See, derivation is given here itself. Kinetic energy is potential energy. With that you are getting D cross multiplication. This derivation
Yes,
understood?
I write it down.
Understood?
Yes, sir.
Very good, very good.
Yes,
Now
sir.
it is clear? Come on, do it on
Yes, sir.
paper. You just write
Yes.
the page number and question number. Question number 2, page number is 295. So for future reference, for you only, for not for me. Whatever you are writing, you put it in one book. That book will help you to understand later. Am I right?
Yes, sir.
How much time you want for this simple thing? Don't calculate, okay? Only substitute the
Sir,
values.
no.
Substitute the form. 2 minutes I'll give you. Okay,
Yes,
I'll
sir.
just go for drink water. Just now I came from market and immediately I joined you. Okay, na? 2 minutes I'm giving.
Yes, sir.
Okay, got it?
No, sir. I'm still writing. Sir, one second. So my pen fell down somewhere. I'm searching for it.
Oh, yeah, go ahead.
Yes, sir. I'm not able to. Yes, but now I start writing. Done, sir.
Okay, show me. May I close this?
Yes, sir.
Show me
Yes, I'm showing, sir.
first one and second one both together.
Yes, sir. This is second one, sir.
2ze square by d. D is equal to 2ze square by what step you have done here? What is that formula? K you are
So
written now. Okay.
then,
Okay. Understood.
yeah, K is
K you are written. Very good.
constant.
No problem. That is also good. 2ze. And after calculation, what is the value approximately you write now? From saying approximately 10 to the power of minus 14.
Uh,
That
it
value
will
is
not
10 to the power of minus 14 is given na. Don't calculate, at least write there.
Yes, sir.
And then first one,
Yes, sir. First
you
one,
write
I've
now
not done the
first.
complete things I've written.
Oh, I have
Yes,
shown
sir.
you na. That ratio you have not done. Ratio I have written on the board na. You have not taken down. May I show you that? Or you know it. Electron orbit by nucleus.
I
And
know it.
sun's orbit by size of the nucleus, size of the earth orbit by earth's sun size is equal to how much? That ratio will come 10 to the power of 5 and another ratio will come 10 to the power of 3. When you divide them, you will get 100. That's all. Very simple problem. You are taking so much time. After understanding, only few steps you have to write. You didn't go for college today.
I went, sir.
Okay, what they taught today in physics?
Sir, today I didn't teach anything, just instructed on how to do the lab manual. Lab manual work they were sent for Dashera holidays.
Lab work they started.
Yes, sir. Like they finished the lab work, sir, but like the lab records needed to be completed.
Okay.
So
Then no class they have taken.
done, sir.
Okay, show me.
They've given study hours for tomorrow's exams.
E by nucleus. Okay, 10 to the power of 5. Their values you have not written. E is what is the orbit size? 10 to the power of minus 15. Ah, okay, okay. Right, right. There you note down that E and electron values because you will confuse. Solar system, orbit of the nucleus of the sun, where your earth orbit and nucleus of the sun, 8. They are divided both together. Next time, okay, 10 to the power of. Right, very clearly, okay? Right, good.
Yes, sir.
But that one you didn't write. What
Sir,
is the
see, that's when I had got it.
yes? Write it.
Sir,
No, no. That second question. Second question. What is the size of the nucleus of the gold atom? How much you got it? That don't calculate. At least you just approximation value is given in the
yes,
textbook
sir.
that you copied on. How much
Yes,
is
sir.
given?
Sir,
How much is
I
given?
had gotten red pen, sir, but in that school, some teacher borrowed it and he didn't give it back.
Hmm.
Yes, sir.
How much is given value? Tell me. D value, how much you got it? 10 to the power of minus
Sir,
16 as
which one, sir?
second question.
8 or 16, sir.
No, these values you have to submit. Just you are not 2
Yes, sir.
into Z. Z is 79, E square 1.6. This then 1 K value you know. That's all. Kinetic energy is given. How much is kinetic energy is given here?
Sir, they've given it as 7.7 mega electron volts.
Okay. Mega electron volts how to convert into the joule?
10 to the power 6.
That is mega. In joules I want na.
Okay, yes, sir. In joules, 10 to the power. Sir, in joules it will become about 1.2 to 10 to the power minus 12 joules, sir.
Okay. It is written here.
Yes, sir.
1.2 into 10 to the power. How you got it? 10 to the power of minus 12. Actual value is given how much?
Sir,
In the question they have given see this much 7.7 mega electron. You know the conversion you
sir,
do
you
it
are
and
not
show me.
presenting, sir.
Okay. In the textbook it is there now. You check it.
Okay, yes, sir. 7.1 electron volts.
Yeah, yeah, do it. Okay. I am sharing it. You see it is given 7.7 mega electron volts. Convert into the joules and show me.
Yes, sir.
You know how to do or I have to do? Tell me honestly.
Uh, sir, I'll do it, sir.
It is matter of 15 seconds for me. Let me see how many seconds you will take.
Sir, calculators, can I use that?
Why calculator you want to use? Simple multiplication 16 into 77. Put the pointer. Oh,
Yes,
what?
sir. 16 to 10 to the power 1.6 into 10 to the power minus 13 is like 1 mega electron volt 2 joules.
Calculator you keep with you whenever I take class.
Yes, sir.
Ah,
Yes, sir. I have it here, sir.
okay, you keep it with you only now
I
because
got
I
it,
have.
1.6.
How much you got?
Yes,
1 point?
1.6 into 7.7.
Here it is given
1.6
1.2
into
into 10 to the
7.7,
power of
which
minus
is
12 is given. Here you check
no
it.
sir, like for converting mega electron volt to
Mega electron volt to.
yes sir, like for 1 mega electron volt is 1.6 into 10 power minus 13 joules.
Hmm. I want this answer 1.2 into 10 to the power of minus 12. You got it or not? You should tell me that.
Sir, I got the answer, sir.
Very good. Show me.
Yes sir, it says in the calculator, just write it down in the book, sir.
No, just show me, that's all. One steps only I will see, not your calculation.
Yes sir. Yes, I'll just
Okay, steps only I want. 1 mega electron volt is equal to 1.6 into 10 to the power of minus 13. How 1 mega electron volts is equal to so much? Oh, okay, very good. So you know that value 7.7. So just multiplied. Okay. That calculator you keep 1.6 into 7.7. Then you will get minus 12 is not coming.
yes.
You should get minus 12 na. Why it is coming that much? Minus 10 to the
I
power of
think
minus 12 it
come
should.
sir, I just tried once.
Yeah. You keep calculator with you because it is needed. But in the examination it will
Yes sir.
not allowed, my dear. Here means I can help you. In the examination nobody will allow
Sir, it's
you.
coming sir, 12.32 is coming.
12 point?
32 it's coming and approximately I think they put as 12.
How approximately 10 to the power of minus 13 is coming?
It's a 12.32 into 10 to the power minus 13 is coming,
Okay.
which is 1.2 into 10 to the power, which is like approximately 1.2 into 10 to the power minus 12.
Okay.
They've taken 1 decimal point, sir.
Yes, correct. Very good. Now it is fine. How you got it that 1.3 into 10 to the power of minus 19 or 18, minus 18? 1 mega electron volts, how to calculate, you know? Because that will help you.
Yes, like that. Uh, so log tables are given the example, right, sir?
No, don't do that. Simple way you remember. I will show you here, you see. Okay?
Sir, you are not presenting.
Presenting. I am just now come here, na? So I am presenting, then
Yes,
only
sir.
I'll show you. 1 mega electron volts, you can't remember like that so many things, because in physics already I am asking you to remember so many mathematical formulas. But this also, if you remember, generally in the examination they will give. If they don't give, also they will. You need to calculate it. Okay. So how to do? I will show you here. Right. Fine. May I show you here, or you will show? You will write. You tell me. What is that? 1
Sir, can you
mega.
0.6 into 7.7?
Uh, how much is given in the log table?
Sir, I don't have the log table, sir, right now.
No. How much you have written in your notebook? 1 mega electron volts is equal to.
Sir, 1.6 into 10 to the power minus 13. Sorry, 16 into
Minus
1.6 into 10 to the power
13
minus
joule. Correct? You got it. You know how this has
Yes, sir.
come? How this has come, you know? If you don't know, may I show you here? Or you know,
Yes, sir.
means you do it. Anything is fine for me. Tell me directly to me to show. May I start?
Sir, can you show, sir?
Yes. 1
Yes, sir.
into mega 10 to the power of 6. Correct? Electron 1.6 into 10 to the power of minus 19. Correct? Into one,
Yes, sir.
it is in coulomb. Electron is in coulomb. Coulomb and volt. Correct? Coulomb and volt is called joule. Remember. Okay. So 10 to the power of 6 and 10 to the power
Yes,
of
sir.
minus 19 how much? 1.6 into 10 to the power of minus 19 plus 6. Coulomb volt will become joule. Right? So how much is the answer? 1.6 into 10 to the power of minus 13 joule. Is it
Yes, sir.
visible to you?
Yes, sir.
You understood now?
Yes, sir.
This question asked in your chemistry, asked in your physics. That's why I'm taken time to explain you. Please remember, very simple. This is every time you are making mistake here. E means 1.6 into 10 to the power of minus 19 coulombs. Okay. V means voltage only. Volt. Coulomb volt will give you joule. You know that formula? How coulomb into volt will become joule? Or I have to write here? Tell me quickly. Say yes or no. You know means yes. If you don't know, I will write. Don't hesitate to ask even small things also. I
Yes,
am
sir.
your tuition master. I want to check
Yes,
your
sir.
depth of the subject. Okay? You don't hide yourself. Your knowledge you should not hide. You should explore. You know it or I have to show. What is the formula will give you? Coulomb into V is equal to
Uh,
joule.
Sir, can you show it once?
Very good. Like that you ask now why to waste time. I will show you nicely. See, what is the definition of the voltage? Work by Q, right? And then cross multiplication, what you will get? Work is
Yes, sir.
equal to Q into V. Q is what? Coulomb, 1 coulomb. And V is what? 1 volt. 1 coulomb into 1 volt will become work. That is equal to 1 joule. Now you understood?
Yes, sir.
Note down, my dear. This is the questions objective
Yes,
type
sir.
they are coming, and many children don't know how to write it. This is even in JE they will ask, even in Neet you will ask, even in your CBSE they will ask. All minute level I am going now because I come to know your depth is very very low. These all things are already
Yes,
in
sir.
first chapter it is taught. But don't hesitate. If I say anything, please sorry for that. Don't feel bad. I am like your
Yes.
okay elder in your
Yes,
house.
sir.
Like that you feel. Sometimes what will
Yes, sir.
happen by anxious, na? I will tell you don't know like this, don't know this. Please, I apologize
Yes,
for
sir.
that because that is my habit of 40 years teaching for so many people. That's why I got that habit. Even my wife shout at me always, why you are shouting like this? But that is become a habit of teacher.
Yes, sir.
So don't take it in your heart. Be friendly with me. Whatever you don't know, please ask me.
Yes, sir.
Ask it. A very simple thing also you ask. If I don't know, then I'll check it and I'll tell you. But don't hide because knowledge is very important for you. For me, if knowledge is not there, nobody will ask. I have retired. I'm getting my money, I'm eating and sleeping. Fine. You understood this point? Have you written? May I go for next?
Yes, sir.
Next question. This. So in the next question, what we have done? Yesterday itself, I told you 2 days back that electrostatic force is equal to Coulomb. That is electron force. That is force between the nucleus and this is equal to centripetal force. This diagram you want, I will show you. Electron is moving in, see, I will show you. Here is the positive charge of nucleus, okay? Hydrogen atom you take, right? This is moving. What is the charge on the nucleus is Q, right? That is
Yes, sir.
equal to a atom. What is that? Hydrogen atom. Hydrogen atom is one proton and one electron. This is the electron, right? Moving, right? Electron is moving. I am not made circle, please excuse for that. The
Yes, sir.
force which is pushing it is called centripetal force, Fc. That value is equal to mv square by r. R is the radius, m is the mass of electron, v is the speed of electron, and r is the radius of electron. That is this. And Fe, electrostatic force, that is Coulomb's law. Q1, Q2, Q1 K into Q1. Q1 means E into E. Both are E only. This is also E. This Q also E, because proton charge also same, electron charge also same. E into E by R square. Correct?
Yes, sir.
These two are equal. So you get this. Fine? Understood this point?
Yes, sir.
Then this we calculated, then radius of the orbit has come. This is the radius of the orbit, you should remember. Just cross multiplication. R is cancelled, 1 R goes there. So mv square by 4 pi epsilon naught into mv square by E square. That is what, okay?
Yes, sir.
So R is there, R is going, E square by 4 pi epsilon naught mv square. That is the value. This is R. Then kinetic energy is
Yes, sir.
half mv square. Half mv square is equal to, how you got it? Which is equal to, how you got it, this E square by?
Sir, we know, sir, from the previous equation, maximum voltage equation, which is 1 by 4 pi epsilon naught, the other value will come, sir. That, and then mass of electron, you have to substitute the value. I mean, mass of electron is constant, so if you just put it as an...
No, from here you have to take here you have to take V, right?
Yes, sir.
mv square you have to take. How to take, you know? Just I will put here. mv square you want means what you have to do? mv square is equal to 1 r will get cancelled, right? So E square divided by 8 pi epsilon naught r, correct?
Yes, sir.
It is not 8 pi, it is actually 4 pi epsilon. Okay? This is 4 pi,
Yes,
correct?
sir.
Then, but kinetic energy means what you have to do? Here mv square, but we know half mv square, na? Here you have to put 2. Here also you have to put 2. Both side I am multiplying 1 by 2. So what you will get? E square by 8 pi epsilon naught r. This is the kinetic energy.
Yes, sir.
Okay. Then potential energy between these two. Which two? Proton and electron. Proton and electron. They have potential energy. That is what is the formula we have come across in the second chapter. That will be Q1 Q2 by potential energy calculated in your second chapter. Second chapter, that is minus Q1 Q2 divided by 4 pi epsilon naught r. This how you got it, potential energy? That is W by Q is equal to V. This is the formula, na? V is what? Minus Q by 4 pi epsilon naught r. This is the second chapter. This Q is going other side, what will happen? W is equal to work is equal to potential energy equal to minus Q. This Q is going there. So Q1 and Q2 by 4 pi epsilon naught R, correct? Then this is Q1,
Yes,
Q2
sir.
is what? Q1 equal to Q2 is equal to E. So what you will get derivation? Minus E into minus E square by 4 pi epsilon naught R. This is what is written here.
Yes, sir.
I think these two are clear. This I
Yes, sir.
taught already last class. For you revision is going on. So total energy is sum of the potential and kinetic energy. This and this. So this is added here. This is added here. Take an LCM. What LCM you will get? LCM is 8 pi epsilon naught R. So you will get here. What you will get? E square. LCM is correct.
Yes, sir. Just E square, sir.
Just E square. That's all.
Minus E square.
Minus E square. Correct. So minus is what is the significance here? Binding electron with
Yes,
nucleus
sir.
with proton. Okay. These all steps you write and show me. Derivation of kinetic energy of derivation of total energy. Note down the question. I will tell you.
Yes, sir.
According to Rutherford atomic model, describe.
Sir, try the question, sir.
You have to write an answer also. These all
Yes, sir.
steps you have to write. It is not for me, my dear. It is for you.
Yes, sir.
Okay. According to Rutherford nuclear model, describe the hydrogen atom to find the expression for radius of the orbit, kinetic energy, potential energy, and total energy. Quickly draw the
Yes,
diagram
sir.
and explain how I explained. Same manner without seeing my derivation. Okay, you can refer if you want your book, but book steps, don't write direct book steps. What I explained you, the same manner you have to write. If you want, once again, you can check it properly. Take time. These are the, okay, na? Take your own time.
Yes, sir.
Take your own time to write all the steps which I have shown you. Do it honestly without saying. That is what I request you.
Yes, sir.
Because you are going to do this expression. This is the 3 marks question going to come, which is asked in your sample paper, latest 2026. You go through your sample paper which I have given in your WhatsApp. Tell me question what you are written. Tell me read out the question.
Yes, sir. According to Rutherford's model, describe the hydrogen atom to find expression for radius of orbit, kinetic energy, potential energy, and total energy.
Of the electron. Very good. Question
Yes,
is
sir.
very clear. Now I am closing this. Anything else? Anything else you want?
Sir, can you just go through the derivation once again, sir?
You go through or I have to explain?
No, sir, I'll just see it, see through it once.
See, but don't write. See, you have to maintain honesty. Finally, it will be. See, here is very simple. This diagram you draw, electronic force you write, centripetal force you write, you equate, you will get here, kinetic energy you will get, then from there R you find out, then kinetic energy you calculate, potential energy you calculate. May I keep it like this or from the beginning?
Yes, sir, one second. From the beginning, sir, one second.
Okay, here is the diagram. This diagram you draw. This is the proton, hydrogen atom structure. Nucleus is proton, electron revolving. There are two forces. One is binding force, which is called Coulomb force. Another force is called centripetal force. Their magnitudes I have taken here. Otherwise, minus minus will get cancelled. I should not talk magnitudes. This is minus force will come. This is also minus will come. Minus minus will cancel. Why this is minus, I will tell you after seeing your derivation. May I go down?
Yes, sir.
Carefully you do. Okay? This derivation, if you understand, then I will start that nuclei, Bohr, atomic Bohr. In that, so much big derivation will come.
Understood, sir.
Okay, right, I am sure. Next, this problem we will do now. You write and show me, then I will go for this problem. It is a very, very simple. Just it will take for 2 minutes. How much time you want to write detailed answer? Everything should be mentioned. E means what, M is what, V means what, and along with the units if you mention, well and good. How much time you want?
Sir, 10 minutes, sir.
Okay, right.
Sir, and also, sir, like, can we stop the class today by 9:30, sir?
Okay, your wish. That is all up to you and your mother instructions. Follow
Yes,
your
sir.
mother instructions, okay? Because
Yes,
if
sir.
writing part they are as it is required for you, I have to sit with you more time. Whenever you have free time, you can come. Is it over?
No, sir, 5 more minutes.
Yeah, then you do this problem also.
Yes, sir.
Work out on paper and show me.
Yes, sir.
If it is over, I will see the things.
No, sir, 1 minute. I'm writing the question also.
Okay, right, very good.
Yes.
Okay na?
Sir, two also just like the calculation.
Calculator use.
Yes, one second.
Check with your this one. It is found experimentally that 13.6 electron volt energy is required to separate the hydrogen atom into proton and electron. Compute the orbital radius, asking you to find out what is orbital radius and velocity of the electron. See that how much orbital radius is 5.3 10 to the power of minus 10 minus 11. See velocity, it is almost equivalent to the speed of light. What is speed of light? Which is equal to approximately it is equal to 10 to the power of 8 meters per second. This is the speed of light. Correct. 10 to the power of 6 is the speed of electron in around the atom. And what is speed of light? It is 3 into 10 to the power of 8 meter per second. And
So I finished.
13 point, how you converted 13.6 into electron volts? 13.6.
So 1 electron volt is 1.6 into 10 to the power minus 19 joules.
1 electron volt is equal to that. Very nice. Good answer. To the power of 19 joules. Just multiply, that's all. Okay. Next. Atomic spectra. 1 minute, let me see your answers, then go for next one. Okay?
Yes, sir.
Show me.
Yes, sir. So this is a derivation, sir.
Diagram.
Oh, the diagram I did, I forgot to use.
Do it now. Do it. Diagram is not
Yes.
there, waste of doing.
Yes,
I am a physics master, I will see only diagram by judging you. And the directions of the forces also you write. One is towards the center, another one is towards the electron. Both will be negative, negative will cancel. You will get that answer. All this detailed
okay, show the
answers.
diagram.
Yeah, 1 minute, just rough diagram. Proton is plus E and electron minus E. Just to show it, radius you show, that's all what is there. And the two forces you show, one is electrostatic force, another is Coulomb force. No, sorry, centripetal force.
Yes, sir.
Okay, show me. That electron, okay. But you have to put orbit, na? Electron orbit, anyway it's okay. But you have to put circle. Electron circle you have to put. Okay. K, Q1, Q2 by Ke, kinetic energy, potential energy, 4 pi epsilon naught R. How you got this E square? That formula you have not written for Q1 by Q2.
I
What?
have written, sir.
No, Q1, Q2 by 4 pi epsilon naught, or where you are written? Show me.
Sir, the force of electron formula, sir.
No, potential energy formula.
I've not read. I've written it here, no, sir. In here,
Where?
kinetic energy plus potential
That
energy is
potential
minus.
direct you are written like textbook, my dear. I have helped you to find out how to potential energy that in terms of Q1, Q2 by 4 pi epsilon naught. You check my derivation. I will show you now. And this
Yes,
next one, next problem you show me.
yes, sir.
Problem what are given. Okay. Electron volt converted. Very good. Next, you got it this much. Then what you got? R is equal to this. And then what are these? 9.9, 1.6 whole square. Okay. 2 into 2 into pi into 2.5, 2.5, 2.2 into 10 to the power. How this is 1 minute? 8. See, when you submit it, E value submitted, okay, then 8, how you got it, this 2 into 0.22 directly why you are written?
Sir, after using calcium, I got, sir.
No, you first step substitution, you do it properly, then you do calculation.
I did it, sir. Substitution is it here,
Substitution
and
where
after
your
that,
denominator, you see denominator what you are written, 8 is not there, pi value is not there, okay, 2 you are written, okay, then E.
sir, this directly
Energy,
say 1
energy,
by 10
energy.
divided
Okay,
by
okay, okay, okay. Energy is given
9
2
into 10
point
power 9 by 2.
minus 18. Okay. Then velocity. Okay, velocity how much? 10 to the power of hand you remove fingers. 10 to the power of how much? 6.
6.
Okay.
6.
What is the speed of light?
Sir, 3 into 10 to the power 8.
What is the size of atom? Approximately.
Size of atom.
Hmm.
Sir, 1.5 to 10, no, it's 10 to the power minus 15 meters, sir.
That is the
So minus 10 meters.
size of nucleus.
10 minus 10, sir.
Okay, right. Very good.
10 power minus 10 meters.
Okay, you are doing well today. Appreciated. Next. Next, what you have to do? Spectra. Okay. Atomic spectra. You know what is atomic spectra?
It's okay, you're not presenting, sir.
Yes, okay. Sorry. In textbook you read, I will ask some questions, you tell me orally. Then if you tell, no need to write. If you don't tell, you have to write. That is the procedure. Problems and other things you have to do. Okay, now what is atomic spectra? You read this sentence and tell me. This diagram you have to draw now immediately. This diagram, 3 characteristics: Lyman series, Balmer series, Fashion series. But in your JEE, 2 more series are there. In textbook it is given O3 only. You read completely and tell me. I will ask some questions, you have to tell. Only just 10 lines are there. Just read out quickly and then you tell me what is absorption spectra and emission spectra.
Yes, sir. I'll just read it once.
Yeah, tell me what is atomic spectra. If anyone asks you, tell me what you will write.
Sir, I'll just read it once by myself, sir, and then I'll explain.
Yeah.
Yes, sir.
Read from your textbook.
Sir, I read it, sir, but can you explain once, sir, because I didn't understand after the the dark background part. Like, in the school they taught in a different way. So like they told that an electron will go to different excited states and then something will happen, but I didn't understand this way. So.
See, spectra means what is that when atoms are excited. Here you see that spectrum radiation. That means what is happening here. Actually, this is the nucleus level, right? And this is the orbital level. 1, 2, 3. You know the orbit, na? So first orbit, second orbit, third orbit, fourth orbit, like this. Have you studied in chemistry that atomic structure in chemistry?
Yes, sir.
In that electron, when it is goes from higher energy to lower energy, what will happen? Its energy is released in the form of spectral colors. That is called emission of spectrum. Tell me, what did I say? When electron transits from higher energy level to lower energy level. What is the lowest one? 13.6. You know this value?
Okay, yes, sir. Lyman Bauman Pascal series, the line.
Yeah, that only I am asking. Here.
Yes, sir. I understood that, but I didn't understand like the in textbook they give bright and dark fringes. No, so that part I didn't understand. I understood the electron excitation, the excitation.
When electrons are excited or absorb the energy, that will go from lower energy to higher energy level. At that time, it will absorb the energy. When it is coming from higher energy to lower energy, certain series will form. Lyman series are first orbit to that is second orbit to first orbit, and Balmer series third orbit to first orbit. Then Passion series is fourth orbit to first orbit. Like that, you will get spectral colors. That is that line series of lines are known as emission spectrum. Okay, absorption spectrum means what? If any gas is sent through the any light, see here, when a light passes through a gas, see in a hydrogen gas, if it is passes some gas now, what will happen? In that case, one
Yes.
dark lines we will get. That dark lines will we get because that energy got absorbed. So such a spectrum we call it as absorption spectrum. Emission spectrum means what? When transition of electrons are taking place higher energy level to lower energy level. That is called emission spectrum. Okay, what is spectra means? In an atom, electrons are moving in a circular orbit around the nucleus in available orbits. It may be that is a hydrogen atom is having one electron, one new proton. Electron may be in first orbit, it may be any other orbit. Okay, so when it is coming to the higher orbit, when electron go to higher orbit, when it gets the energy. Are you getting it?
Yes, sir.
So when electron is given, it will go to lower energy level to higher energy. Lower energy means first orbit. Higher energy means second, third, fourth, like that. Okay. So at that time when it is
Yes, sir.
giving, when it come back, suppose if it is coming from fourth orbit to first orbit, what happened? It release that energy. Whatever extra energy is there, that will release. That we are going to talk in Bohr theory. Right? So atomic spectra will come
Yes.
only when electron transition take place. Certain lines are observed because of the emission of energy. That type of emission spectra is called, that type of lines are called emission spectrum. And absorption spectrum means when certain, in a certain gas, when you send the light now, there will be missing of this electron, this atomic wavelengths, this wavelengths. That will help you to identify what type of gas. Okay, you can easily find. So with the help of this only, we are in a position to understand that the sun has abundantly hydrogen atom, hydrogen gas and helium gas. Why? Because the sunlight, when it is coming from the sun, when it is passes through the vacuum tube, it will observe, it will give certain colors. That colors will help you what is the missing in the spectrum of light of sun. Is it boring?
No, sir.
Okay. Right? Write the question. Write the question now. What do you mean by atomic spectra? What do you mean by atomic spectra? Describe the two types of atomic spectra, means emission spectrum and absorption spectrum. Write two types of, describe the two types of atomic spectra. Okay? Draw a diagram to show the Lyman series, Balmer series, Fashion series. Second question. Second question, what you have to write? Write the what I said. Write, describe, draw and describe three spectras,
Yes.
Lyman, Balmer and Fashion with their wavelengths. So this is
Yes,
not,
sir.
this will be visible light wavelength, this portion, because you know that now 300 to 700 nanometer visible light. This is the infrared light. Their wavelength, if you know, you can find out in your this one. What are the things are there? Ultraviolet, infrared, visible light. These three things are there in the spectra, right? Draw and explain. And what are the uses of this atomic spectra? Atomic spectra I will help you to find. One is to find the gas, identify the gases. Here it is given type of fingerprints for identification of gas. You can find what is the identification of gas. If you send the light through certain gas, now what will happen? You can see dark lines. These dark lines help us to find the gas in which the light is going in a spectrum of white light. That is a one use. Second use is we can find the gases in the stars, around in the atmosphere of stars. For example, sun. Sun is the, what is sun? Sun has lot of helium gas and hydrogen gas, which was discovered by this spectras only. Understood?
Yes, sir.
So how they described, when that sunlight goes through the atmosphere of sun, certain wavelengths are going to miss. Those wavelengths studied in a spectrum, that is Vibgyor spectrum. In that some dark lines are seen. These dark lines is explained that the sun atmosphere use quantity of hydrogen and helium gas. So indirectly we can find out. You can't go go to the sun and find out what are the elements are present in sun atmosphere. Will you go? Because it is having around 7,000 degrees Celsius. It is 10 to the power of 7 degrees Celsius. Is a very, very high temperature. If you go to certain distance itself, you will become smash. But how to find out what is the atmosphere of the sun? That is why we are going to discuss about nuclear fusion and fission. These all things are might have taught you in your school.
Yes, sir.
You are not telling anything then. I thought you will explain. This is all theory part only. Okay, how many questions you have written?
Sir, two questions, sir. what do you mean by atomic spectra, absorption spectra, and emission spectra? And I have to draw the neat and label diagram of the emission spectra, and then I have to draw and describe the Lyman, Balmer, and Pascal series, and along with the wavelengths.
Then another one, use of spectra I am asked na. Right? Two uses just now I told you na. When the sunlight
Yes,
passes,
sir.
when light passes through the gas, you can find out the what is the content of the gas. And the second one is sun's atmosphere. I told you, right? Two uses. Show me now. Then I will start a Bohr atomic model. It is a very big thing for us. See the derivation, how difficult derivation is. So many points are there. 1, 2, 3, 4, 5, 6. Simply done in a textbook. Children will struggle. This derivation nobody will teach on the board. They will say you read from the textbook. Nobody understand. Then go for reference book. That also I used to solve on the board, but children will not listen at all because they will be talking only so much derivation, so many points. If I write now, they will not be stable. Simple things they will understand. This much derivation, I don't think. So this is actually finally the energy, nth energy. What, may I continue, my dear?
Yes, sir.
What is the time? You said some time.
So 9:30, sir.
You finish that two things now. Complete it and show me.
Yes, sir.
Line spectra means atomic spectra means what? Two types. What? How they produce. Then draw the diagram and its atomic level. Then after that I will start Bohr atomic theory. When you come for tomorrow class, you need tomorrow.
Yes, sir.
Time you mentioned 1 hour before so that I will be get ready for you. When you get up immediately you decide what time. How much time you require for this?
So about 10 to 15 minutes.
Okay, do it. Finish it up. If you want, you can see the book also. You can see the book and
Yes,
write.
sir.
Okay? But you have to finish writing part. Today you are doing very well. Okay? So do it like this. Those who are seeing live classes, please like it and subscribe the channel. It is in YouTube. This is learning class of physics, class 12th. Topic is atoms. Subtopics which I taught just now is the textbook version. Rutherford model, then calculating the how much time if you compare that atomic orbit and then solar orbit. 100 times is greater our atomic size. We feel that solar size is very big, but it is not correct. When you compare them, so much gap between the nucleus and electron. That is the reason why the alpha particles are going large number of alpha particles without scattering. It will pass through gold foil. Only few particles, 1 in 10,000 will retrace path. Okay. So then question 1 over, question 2 over, then very important derivation electron orbit. That is 3 derivations I have done here. One is about radius of the orbit, other one is kinetic energy, third one is potential energy. Then we have seen that total energy is in negative sign. This indicates that electron is required energy to liberate. If you provide this much energy to electron, it will come out from the orbit with zero kinetic energy. More than this, if you apply, it will be come with certain kinetic energy. That's what actually you are going to see here. Then this is a direct question asked on the energy. Now spectra I just now told you. So spectra will come, atomic spectra will come because of transition of electron from one orbit to another orbit. So if the electron coming from higher energy to lower energy, it will loses, so it will emit the energy. That you call it as emission spectra. And when the electron go from the higher energy to lower energy to higher energy, it will absorb the energy and go to higher energy. That is called absorption spectra. So these spectral lines help us to find out what are the gases are present in which, when light goes missing, lines will help you to find out the identification of gas. So such a things are experimentally found that atmospheric sun's atmosphere, mostly we have hydrogen gas and helium gas. That is found when a sunlight is passed through the prism, we get a high power dispersion. If you see in the spectral, that is in the spectrum of red light to violet light, it is observed certain lines. Those dark lines are shows that it is the atomic structure. It is the element of hydrogen and helium. So that concludes that all the stars have, most of the stars have hydrogen and helium. So that hydrogen convert into helium and the helium further converts. That is the one astronomy, birth and evolution of the stars. You will learn if you are interested. You can go for the star's birth, photostars to the star, brightness of the star. Then after that, supernova, neutron star, black hole. These all are observed on the basis of the spectra and other physics concepts. Okay, thank you for watching my YouTube live course. Pranav, if you have done, you can show me, then I can close this, both the
No, sir, just
things.
out.
Yeah. Do it slowly, don't worry. Anyway, you are free, I am free. I just check only, that's all. So today class is interesting or very boring?
Definitely, sir.
It is some use is there better than your school, or it is boring for you?
Yes, sir.
Some information you got?
Yes, sir.
Okay, those things you remember, my dear, and keep my name. And you can also
Yes, sir.
tell your friends to how, if they have doubts, let them, you give my phone number or WhatsApp number, let them come for any type of CBSE question, NCRT questions are there, that I will tell you. But I don't do that.
Yes, sir.
This objective type, this all, it will take lot of time and lot of stress will come on my mind. So I only prefer to discuss basic things in physics, like textbook examples
Yes, sir.
and derivations. These things, anyone is having doubt, your friends may be there now. There are so many, you can share with them. They may be struggling for understanding physics.
No, sir. Actually, like they're all more focused towards JE. They don't really care about CBSE.
CBSE or
Maybe in January when
yeah, January when
there's
they
some
come na, at
memory.
that see CBSE, if they don't care na, getting JEE, because JEE they are taking CBSE marks. Some percentage they are adding, you know. You know, some percentage they are adding.
No, sir. This actually like 75% plus. If you get, then you will get into a college. But if you score very well in mains, but if you don't get 75%, then you won't get into any college through mains.
Okay. This CBSE marks they are not adding for ranking.
That's for CET, sir. CET is 50% CBSE and 50%
Then
KCET exam.
CBSE is only very important. That JEE very difficult questions will come. JEE solutions one by one. Some solutions I have solved and I kept it in YouTube. If you want, you can see. I will show you one day when you are free. When topic comes now, I will show you that polarization and all. One I have done, but it is not there in CBSE. But JEE they are asking, Neet they are asking. Children has to go for coaching classes only. So lot of demand physics in Bangalore.
Yes, sir.
So 29th onwards you have holidays.
Yes, sir.
Will you join the class then?
Yes, sir.
All basics revision only I will do because that is only lagging in you. What I observed. That one thing I want to ask, whatever you are doing now, you can take screen that a photo from your laptop and send to me now. Will it be possible for you? Camera you open and then take the click and
No, the
send.
photo is blurry in the laptop, but I'll try, sir. I'll send it.
Huh?
I'll send it, sir. I'll send it.
No, that you have not sent till today. I asked even madam also. Madam said she will send so much. I have to correct. It is for your benefit
No, sir, like
only.
whenever you ask me, like last time, for example, you asked for doing the few questions, no, sir.
Ah.
I showed you during the class itself.
No. That is not enough. That will not help you because I just putting in 10 seconds. I cannot judge your answer.
Yes, sir.
You have to properly write and what are the mistakes I will write there. I'll send it back. You can take it from your this one. You take just simple, very simple. You take the pad and put it that paper in front of the camera. And camera you open and click it like your photo. It will come there. Why you want cell phone? You don't know that.
I know, sir.
Then do it that way because lot of mistakes are there. No, I don't feel bad. Mistakes in the sense you are skipping things. That is skipping now. It will trouble you in your CBSE exam. I am telling. It will lot of marks you are going to miss. If you don't do it like that, I can't help. Until unless I see the paper, your answer sheet, your correction, I will give you correct picture of yours. That is for your benefit only, okay? Nothing, nothing is my benefit here. So whenever the class is over, immediately you send it photos. Just sit for 5 minutes, 10 minutes. You can take the photo and send it to me. How much time it will take? Since the class, I was asking you.
Yes, sir.
Since first class onwards, I am asking you. Send, send, send. Nothing is coming. Later, this all you have to by heart. Write 5 times, 3 times. All these things will help you understand. Objective type, JE question, all will come from here only. Any question you ask, I will show you here. Objective type. Nicely explained here. Definition, if you don't get, you have to see the summary points. 9 summary points are there.
Yes, sir.
Ora?
It's almost good, sir. Done, sir.
Okay, right, very good. Okay, show me.
Sir, actually, like the pen's handwriting didn't come well because ink almost got over. Can I just read it out?
No, no, show me. I don't want.
Yes, sir.
Whatever the way, I have seen so many students writing now. I can easily guess. Okay. That wavelengths you have not marked properly. Balmer series, Lyman series, fashion series, not nanometers, it is not mentioned here. Yeah,
Right.
91. But very detailed I want, na? Okay, anyway, you practice later. Come on, now read out.
Yes. Yes, sir.
Open the screen.
Absorption. Sir, absorption spectrum is from lower energy to higher energy.
No, what
When
is atomic
electrons move from
spectrum?
lower.
What is atomic spectrum? You are not written.
Okay. Yes, sir. So like when electron is excited or de-excited, it either loses or gains energy. So when that happens, it it emits certain amount of energy which comes in atomic spectrum. And there are two types of atomic spectra, which is absorption spectra and emission spectra. Absorption spectra is when electron moves from lower energy to higher energy level, where it absorbs some energy and goes to higher energy level. And emission spectra is when the electron releases light or energy, and when it moves from higher energy level to lower energy level. And there are three levels of emission spectra. Which first one is Lyman series. Lyman series is from 91 nanometer to 365 nanometer. And next is Balmer series. Balmer series is from 365 nanometer to 820 nanometer. And everything exceeding from 820 nanometer to 1875 nanometer, it's Pascal series, sir.
Which series is visible spectra?
So the visible spectra is
Which
I
spectrum
forgot,
will
sir.
be seeing that? Hey, that is Lyman series, Balmer and Balmer series, which is having nanometers, na?
Okay, sir.
400 nanometer to 700 nanometer is wavelength. Which is producing that wavelength? Lemon series, Balmer series, or Passion? Which one is having that 400 to 700 nanometers between?
400 to 700 is Bama series.
That you have to tell, na? Okay, uses? I can checking. Uses.
So sun's atmosphere is really high, and sun's temperature is really high. So we can't actually go there and test out what gases are there inside the sun. So from the emission spectra of the series, we can find out what gases are present on the surface of the
Hey,
sun.
it is not a emission spectra, it is absorption spectra.
The absorption spectra, so I'm mistaken.
Cut it and write. All mistakes you will write.
No, sir,
Because,
I've written down the spectrum, absorption spectra by mistake at emission spectra.
okay, what is absorption spectra in solar spectrum?
Sir,
In solar spectrum, what do you mean by absorption spectra? Which I explained you. When you study the high resolution of spectrum, what happens? Some black lines are observed that you are not written. Some black lines are observed in the absorption in the spectrum. That is because of missing of wavelength in the atmosphere. That helps to find out what are the elements present in the atmosphere of sun. This much is required. You write and show me that part. Otherwise, will you send it? Then other second use what it is?
the second is I don't know, sir.
Hey, when light when light goes in certain gases, there is a missing of wavelength. That missing of wavelength help us to identify the gas in which it is traveled. So, what is the mixture of the gas we can find out? Identifying the gases in absorption spectra. You laugh yourself. What, my dear?
Yes, sir.
What is the second use? Tell me. It is written just 10 lines. You can see here only 10 lines is there at the most from year to year. It is very clearly written fingerprints of identification of gas. What is this? English. This much. This is the first use. Second use is solar spectrum.
So element.
Okay, tell me.
In school, they had told something about elemental analysis or something, sir.
At school, you leave it here. You don't know any thing from the school. I am not bothered about your school and college. They are training you in your JEE. I am training you CBSE exam. You see that CBSE question paper and tell me how difficult question paper. Sometimes it will be difficult for me also. Such a question paper, if it comes, you have to get pass marks. Na? If you fail, what will happen? Your JEE, they will not take. Your level of understanding, I know it only 30 to 40% only. So you are fit only 30% of your CBSE. Not that going to 70%. According to me, I am guessing it. Okay, don't feel bad saying this. Do you?
No, sir.
That's why I told you when you get the stress now, you laugh. Then you will go on, go ahead. You should enjoy the class. Not that every time writing, listening. This will be there. Teacher will say so many things, but you should be strict with you. Okay. You will be going, I am going to make you 70% in the CBSE. You want or not?
Yes, sir.
And then you have to listen to me. You have to
Yes, sir.
write. Okay. Now you tell me, you want to tell those things, or may I close it?
Sir.
May I close the meeting?
Yes, sir.
Okay. You
Yes,
feel
sir.
bad about me.
Thank you, sir. No,
You
sir.
you laugh at least once. Let me see. I used to laugh, but you are not doing that. Okay, I will open the camera. You laugh and show me.
Sir.
You open the. You laugh like this here. What is there? Physics, chemistry, mathematics. It will be there in your on your head. They will dance only. Okay,
Yes, sir.
and you have to catch hold of them.
Yes.
Okay, you laugh loudly. Let me see. You can't laugh even.
Sir.
You have to laugh like me. Like that. Laugh and see. How
Sir, I'm
stress.
laughing, sir.
But
I
I am
cannot,
not getting
I
sound.
don't make sound.
You laugh when
Yes, sir.
you
Like when I laugh, sound doesn't come, sir.
okay when you have a stress now you laugh. Yeah, everything will go off.
Yes.
Your teacher
Yes, sir.
shouting, parents shouting, and your meeting shouting. So many things on your head dancing. You have to enjoy the class, right? Thank you very much. Good night.
Yes, sir.
Nice. Enjoy the class.
Thank you, sir.
Huh? Learn
Yes, sir.
physics. We are learning. I am also learning along with
Yes, sir.
you. Okay, don't think that I am the master. I have so many doubts in physics itself. Who will clarify? I am seeing here and there and getting clarification. That will be helping you. Right? Bye. Good night. Take care.
Yes.
Do
Thank you,
well.
sir. Yes, sir.
Okay. Message me that every time you message me, I will respond. Thank you.
Yes, sir. Thank you, sir.
Thank you very much. Those who are seeing my online class, I am closing it. Good night.